Section 4.1, Organizing Data into Matrices. A matrix, or if I want a plural, that's matrices, is an array of numbers written in brackets. In this example, I have a matrix, and I'm going to represent this matrix with a capital letter. Therefore, matrix A has a set of elements inside of my brackets. Here it's organized by 2 vertical columns and 3 horizontal rows. We identify matrices by their dimensions, and they're organized by, first, the number of horizontal rows by the number of vertical columns. So in my first example, I have matrix A. I have 3 horizontal rows and 2 vertical columns. And if I set it up in this organized manner, I have a 3 by 2, or 3 rows by 2 vertical columns. And this is read as a 3 by 2 matrix. On this slide, we want to state the dimensions of each matrix. And remember, the dimensions are identified by the number of rows, by the number of columns. In matrix B, we have 1, 2, 3, 4 rows and 1 column. Matrix B is a 4 by 1. Matrix C has 2 rows by 1, 2, 3, 4 columns. Matrix C is a 2 by 4. Matrix D has 1 row and 1, 2, 3 columns. Matrix D is a 1 by 3. Not only can we identify a total matrix by its dimensions, by rows and columns, we can identify each element inside the matrix by their position in the matrix. For example, here I have A, 1, 1. That tells me that element A, 1, 1, is in the first row and the second number means first column. Also, element A, 2, 3 tells me that that is in the second row and the 3 represents the third column. Therefore, that tells me that the first number tells me the row it's in, the second number tells me the column it's in. For example, 2, 1, second row, first column, 1, 3, first row, third column. In this example, they want me to identify the numeral or element that is in the identified matrix. Here I have matrix A, and I want the element in row 1, column 1. And that would be row 1, column 1 would be 4. Here I want matrix B. I want the element in row 2, column 1. Row 2, column 1. That element is 12. Back to matrix A. I want row 3, column 2. Row 3, column 2. That element is a negative 1. B, 1, 2. Back to matrix B. First row, second column, 2.2. B, 2, 3. That would be second row, third column, or that element is 0. In this example, they want me to use the data in this table and make a matrix B with the columns representing years. And then we want to identify B23 and tell what it represents. My matrix B will have the years vertical and CDs and MP3s as the rows. And that would be 80, 70, 50, and 20 for the CDs, and then 20, 30, 50, and 80 for the MP3s. And the years 2010, 11, 12, and 13 are represented vertically. Then they want us to identify element B, row 2, column 3. Row 2, column 3. And that element is 50. On number 2, they changed the directions by wanting us to display data in a matrix C, but in this situation, they want our rows to be in years. Therefore, this would be 2010, 11, 12, and 13. And then our vertical columns would be the CDs and the MP3s. In this case, I would have 80, 70, 50, and 20. And in year 2010, I have 20 MP3s, then 30, then 50, and then 80. And now they want us to identify element C for 2. That would be row 4, 1, 2, 3, 4, column 2, which would be 80. The graph represents 3 weeks of sales for a newsstand. Red, newspapers; green, magazines; and blue is periodicals. Here they want us to record the data in a table. Week 1, I have newspapers. I'm going to estimate that to be about 160. Magazines, it's going to be about 145. And periodicals is going to be at 200. Then I have week 2. I'm going to estimate the newspapers at approximately 145. The magazines, about 210. And the periodicals are going to be about 100. And for week 3, I have newspapers pretty close to about 240. My magazines are going to be about 50. And my periodicals are going to be close to 150. These are just estimations by my graph. Next, they want to show the data in a matrix. And we have it set up. My rows are going to be newspapers, magazines, and periodicals. And my columns are going to be the weeks. So I'm just going to transfer this into a matrix. 160, 145, 200, 145, 210, 100, 240, 50, and 150. And then they ask us, what do the columns represent? They, of course, represent our weeks. And what do the rows represent? They, of course, represent newspapers, magazines, and periodicals. Our next example, we have 2 charts. The number of students that played sports. In 1970, who played and did not play, and that is for boys and girls. And in this chart, we have the year 2000, who played and did not play, representing boys and girls. Our first direction is the used information to create 2 2x2 matrices. My first matrix is going to be for 1970. The boys and girls as rows, and played and not played as my vertical columns. That's going to be 42 and 6, 34, 68. And then my next one will be for the year 2000. Again, boys and girls as rows, and played and not played as my vertical column. So that's going to be 62, and 48, and 32, and 40. Let's complete the example. Here in part B, they're going to ask what percent of girls played sports in 1970. There's 2 ways to look at this. We could look at this just as a group of girls, which would be 6 plus 68, which gives us a total of 74 girls. How many played out of that total? 6 out of 74. which is approximately 0.08, which is a percent. Or we could look at it as a total population, which is the sum of the boys and girls, which is a total population of 150. 6 out of 150 is approximately 0.04, which is about 4%. The same question is asked for Part C, but for the year 2000. Again, just as the population of girls is 48 out of 88, which is approximately 0.55 or 55%, and out of the total population, which is 182, 48 out of 182 is approximately 0.26, which is 26%.